Hello there, CodeMaker4 here. In JavaScript, when you make an unassigned variable, the value in that variable will be undefined. This special value of undefined protects you from yourself from accidentally reading an unassigned variable. C is a different programming language, which is much faster. However, to make it that fast, these safeguards have been removed. Let's try to make an unassigned variable in C. First we make our basic main function, then we create an unassigned variable, let's just call it unassigned, and last but not least we're gonna try to print that unassigned variable as if it's just an integer. When we compile and run this program, it's gonna print out a random integer. That's weird. We never assign an integer, so you'd expect the value to be 0 or something else special. But again, C has no safeguards, so what's printed instead is just whatever random value happens to be at the memory at the variable unassigned. I'll explain this in detail later. First, let's have some fun. I prepared this program which makes an empty list, and with this loop, we're going to be reading items from this list that don't exist. You see, the list is 0 elements long, but we're still going to be reading elements. And this loop goes on forever, actually. Let's see what happens. As you can see, the program prints out a lot of junk. This is actual junk data that just happens to be in memory, next to the place where this empty list was created. Then we see some memory that does seem to make sense. This is actually all data that's supposed to be in our program. It's information about my hardware and the operating system I'm using. This is data my program can normally access using special variables, but this variable A is not really meant to access that. And at the end we get our infamous segmentation fault, core dumped. This is basically the memory police of my operating system going like, hey, you're reading memory that you're not supposed to read. I'm gonna sentence you with termination and core dumping. But that still doesn't really answer what all this is. Why isn't this all zeros? I mean, we never specified any value to be there, so you'd expect it to be 0 or empty in some other way. Why is it all this random junk? So let's just say this is take 7 of the following segment. I'm afraid it's gonna get a bit complicated, so there's subway surfers in the corner for anyone with, concentration issues. I get it, I have it too sometimes. But long story short, this is a representation, totally not the scale of all of your memory or random access memory. This is the memory where your computer stores currently running programs. So say you want to, program something in Python, so you open up your IDE and it stores some data, but it doesn't work, so you open up a web browser and use ChatGPT, and it also stores some data, and that's fine. Your operating system will reserve some blocks of your random access memory to those programs to make sure that all of the programs will take an appropriate amount of RAM and there's no conflicts between two programs trying to use the same segment, which would lead to disaster. We don't want that. The operating system makes sure that doesn't happen. So when we launch a third program to, we got bored of programming with Python, so we just look up the lore of lorem ipsum and why it's everywhere. And we are so bored of Python, we decide that lorem ipsum is our life right now. We are not going to do anything with Python and ChatGPT, and we close those programs. So we close the IDE of Python and we close the web browser. But as you can see, the data for those programs is still there, because when you close a program, all the data that is in RAM isn't deleted. The only thing that's deleted is a little bit of memory somewhere else that says which parts of RAM are meant for what programs. Again, I'm simplifying a few things here. To repeat, the data is there, it's just no longer reserved. So if another program comes along and wants to use some memory, they can take that memory totally fine. So remember the load program we wrote with the unassigned variable? Well, we decided to run it right now because lorem ipsum is also boring, and our operating system sets aside some memory for it. There is space at the beginning of RAM, so we'll just put it over there. This is totally fine, because before the program runs, it sets some default things, but only the stuff it really needs is overwritten, nothing else. So as you can see at the top, there's some code. Again, I'm simplifying. This wouldn't be raw text that's put in memory. And at the bottom, there's all the stuff that we were able to read out from a previous experiment. But in the middle, there's some unused space. This is space where variables and arrays that are used in your program can be stored. So the program has been initialized. It's loaded into RAM, and it's time to run the program. What happens is that we're going to be creating a variable. So C is going to use the same concept of just finding empty space within our program, and says, yeah, here's empty space, so our variable named unassigned is going to be over here. There is already data there, which is fine, because normally you put data there before trying to read from it again. So say you want to put 1, 2, 3 there, everything that used to be there gets overwritten, and if you try to read from the variable, we'll just get the value 1, 2, 3. But we never assigned it. So what happens now is that the characters PRIN are going to be interpreted as an integer, and this goes horribly wrong, and we get a somewhat random number as a result. Same thing happened when we made the array. It just gets put in a random bit of memory, and then when we try to read past the array, it's just gonna keep on reading data from our program. It first goes through the random part that wasn't really cleared or anything, where we get lots of random junk. Then after that, there's all of the program arguments, and after that, if we keep reading beyond that, our operating system comes in and is like, wait a second, you're reading past what the program is allowed to do. This is for like security reasons. You don't want one program to be able to read what another program is doing. So the memory police comes along and is like, yes, this is bad. I'm gonna sentence you a segmentation fault. We're gonna dump your core. Stuff happens. The program gets terminated. And again, this leaves a mess. But as long as you initialize your variables before reading them, as in overwriting what mess is here, it's going to be fine. And you'll never have issues. That's why you always initialize your variables. Anyways, I'm CodeMaker4. I don't really have an outro yet. I do have a Discord server. And I also have a Patreon if you want to financially support what I do. Recording this video and editing it took a good part of an afternoon and an evening. Patreon, Discord, links in the description. Subscribe if you want more stuff like this, and bye.